originally presented this to a group called InfraGard, which is a partnership between FBI and law enforcement agencies and members of the 16 critical U.S. infrastructures. And you can see on the screen here, it has everything: communications, chemical and critical manufacturing, defense, food, communications, healthcare, you name it. There's a critical infrastructure that deals with that. My apologies in advance. I am long-winded and I use PowerPoint, and a lot of people don't survive it, so I apologize for that up front. Okay, when you set a nuclear device off in the atmosphere over, say, 75 or 100 miles in altitude, there's a 3-step pulse that comes off of the resulting physical effects, and they're called E1, E2, and E3. How very engineering and exciting. If you look at the first, that's called the E1 or early time pulse, that pulse basically shows up at its maximum amplitude within 100 millionth of a second. Okay, that's pretty darn quick. There's not too many things in the universe that are fast enough to catch and stop something like that. Okay, and then after that little peaky pulse goes by, then there's the intermediate or E2 time period pulse. And it's very similar to a lightning strike nearby, same kind of effects. And so we'll probably not talk much about that. Then there's the late time pulse, which is broken into 2 pieces. And one of them's called the blast and one of them's called the heave. And if you look in the third yellowed in part here, you'll see there's 2 humps there. The first one is the blast and the second is the heave. And it has to do with the physical effects of the ionized remains of the bomb casing. The first thing, the bomb casing radiates away at about 100 billion miles an hour, very, very fast. And that high-speed movement of metallic particles, ionized metallic particles, creates one electromagnetic wave. And then that huge cloud convectively lifts up like hot air in a cool room, and it rises up, and it continues to do so for almost 2 minutes. So there's a second pulse that lasts a long, long time. So that's E3, A, and B. Whoa, what is that? Warning, warning. I'll try to remember what the heck that was. That's just a title. We must be using that wannabe PowerPoint program, right?
That's the real PowerPoint.
Wow. The only time I've ever had that happen was when I was using that open office thing. My wife says, it's just the same. It'll work great.
No, that's the genuine.
Okay. Well, anyhow, so here we are. With the E1 pulse, basically it radiates typically a field of 50,000 volts per meter. And what that means is, if you look at this funny little picture I made, if you have a 1 meter long piece of wire, that piece of wire will have 50,000 volts induced on it. If you have a piece that's 100 meters long, it'll be 5 million volts. So a long power line or a chain link fence or a antenna guy cable or something like that pretty much picks up a lot of voltage charge. And if you're talking about electric transmission lines that are a mile or 2 or 10 or 100 miles long, it picks up a big, big, big electrical charge, but most of it bleeds off into the atmosphere via corona, or it arcs over the ground. That would be fine and dandy, except for the fact that the transmission lines in a typical electric utility, they have different classes. And if you look at here, it says the 1.2 volt class transmission lines or the 2.5 kV, they have these voltages, 30, 45, 60, as that's what the insulators are designed to withstand. And as you get higher and higher in voltage class, there's a whole lot less cushion between, from 1.2 kV to 30 is a big difference, but from 15 to 95 is only 7 times. Anyhow, so what happens, or what can happen, when you have this very, very, very fast pulse that lightning arresters can't stop? Let's say we irradiate a high voltage transmission line somewhere, and these are high voltage transmission line insulators. And if you look carefully up here in the top left, here's at the instant of the injection of the high voltage pulse, you start to see this little tiny spark start to creep off of the center of the insulator. And then the next picture, you see some more of it. And then the third, you see there's actually an electric arc that jumps over the insulator bells. And then if there's actually electric power being carried by that conductor, basically the electric power seems to think it needs to follow that electric arc over because it's a conductor, and it basically sets fire to the insulator, if you will. It sits there and burns across that porcelain until it overheats. Here's another picture. Here's another picture on the left side of a flashing over insulator string. Okay, if you have a transformer that's got these big bushings and bells on it, there's a possibility that you'll destroy the bushings and not kill the transformer and its iron core on the inside. That's not guaranteed, but it's always possible. All right, we're talking about the E3 pulse here. What happens with the E3 EMP pulse is that when that wave gets down toward the ground, basically it causes a differential voltage, ground voltage, over a geographical area. This is kind of a schematic of a pair of substations. If you look, you see the little arrow moving around. That's the secondary or high voltage side of a three-phase substation transformer. And here's another one over here, the high voltage side, and it might be 100 miles distant. Well, because of the distance, the actual ground potential is very likely to be different under these conditions. What that means is that since the ground is conducted through the ground and then up through the ground connection into the transformer along one of the high voltage legs and then back down to the ground at the far end, you actually get an electric current. You have a DC potential that is impressed on top of that high voltage AC. And that is really bad. AC transformers do not like DC, okay? The first thing that happens basically is the DC superposed on the AC causes the waveform shape to change. It distorts it, and that causes saturation in the transformer, and it causes an increase in reactive power, both of which are bad for the utility system. Okay, so the bottom line is you have, if you follow my little arrow here, you have the superposed voltage onto the overhead conductors, and you have the ground differential voltage imposed on the ground leads. All of that weird electricity causes the saturation of the transformer core, and this is what happens, bluey, and it's usually pretty spectacular. Okay, what I'm going to propose here real quick is basically a scenario where somebody that doesn't like us decides that they're going to attack us with an EMP device. And all of the things that I'm going to talk about now are out of my imagination, but I promise you that they're well within the capabilities of just about any technically competent person. Okay, what we have here is an ocean-going ore or coal bar ship. And you can see it, there's multiple hatches across the top of it. Wow. Anyhow, what we could do is mount this missile launcher. This happens to be a North Korean Nodong or a Iranian or Iraqi Shahab-3 missile. They're basically built on a trailer tilt up. So let's put one of these inside the inside of this boat. This particular missile is capable of carrying a 2,600-pound warhead, and it's only 55 foot tall when it's erected. And I promise you, it'll fit inside one of our coal barges. That's me standing down there in the bottom of the coal barge just for scale. So we take this little apparatus, and hey, you might even have some fake coal in the other hatches, and the one in the middle is the one that's got Mr. Bomb. And you drive it up the St. Lawrence Speedway and across to Toledo, Ohio, in the Great Lakes. And before sunup the next day, basically, you open the hood, the lids on the cargo, and set the missile off, and whoosh, up it goes. Okay, This missile that the North Koreans and the Iranians present or have had for many years is capable of getting way, way higher than is necessary to make an effective EMP device. So in my imagined little scenario here, we shoot from Toledo, Ohio on the Great Lakes and have it explode directly over Chicago. Okay, why do I pick Chicago? Well, this is what it would look like. I know all this Klingon looking stuff is kind of confusing. But anyhow, that is actually a picture from the Starfish Prime nuke EMP test in 1962 that the Americans did. That's what it would look like. The sky would light up. Okay. Online, I found this report by a company called Metatech, and it's basically the effect of an E3 attack on the U.S. power grid. And they're kind enough to publish all of this online. And basically, here's some charts and graphs out of that report. Basically, you can see in the middle of the green and red, that's Chicago. And when the device went off, basically, in this model, this is an actual US model that was done. All of those green and red spots are damage to the US utility grid. Okay. In this case, the model, the US model basically said if they did this and generated 50 kilovolts per meter of radiated power, you would shut down the entire grid. Now, this is not speculation. This is not made up from somebody. This is an actual computer model using actual numbers. So the terrorists that decided they wanted to do this as a backup plan, while they were either approaching the US coast or while they were going up the St. Lawrence River, if they had issues, like somebody found out and decided to cause them issues, they could go ahead and launch on New York City and cause almost exactly the same damage to the United States. Okay. And again, the entire US grid would be expected to collapse if you set off the same device over New York City. There's 5 or 6 places in the US that are particularly sensitive, and this report will be glad to tell you about which they are, in case you're interested. Okay, the dots that you see here are high voltage transmission line transformers. They're 300, 400, 500 kilovolt transformer substations. And all of these stations were predicted by the report to fail. It doesn't look like there's going to be a lot of electricity left, does there? Okay, this graph is basically, you see the blue line is kind of an S curve. All of the data points there are transmission lines that have more than their trip point or their normal maximum load on the lines. The red ones basically are saying all of these transmission lines are going to pop breakers if they work, or the lines are going to fail because there's that much EMP current carried in the transmission line. Okay, so here we are in hometown U. When I wrote this presentation, I was still working for the utility of the Northern Hemisphere, so I was careful about what I said. Here we are in Northeast Florida. The effects resulting from that EMP strike 1,000 miles away in Chicago, the first day after it happens. Okay, basically, you're going to have only a few cell phones functioning. The towers at the E1 pulse, the real high voltage pulse that came through and killed the electronics. If it killed the tower electronics, your area is dead. Okay. Also, the E1 pulse is likely to kill the controller, the electronic controller and transfer switch on the emergency power generator. The next problem typically is going to be on-site for fuel for the generators. The emergency generation is only going to last for 1, 2, or 3 days, depending on the size of the fuel tank. And don't count on the company's fueling contractor to be able to keep those tanks filled because, hey, who can fill the tank trucks up? By the way, cell phone providers prioritize public safety employee communications. So even if you have a cell phone and cell towers that work, they're going to be overrun with police, fire, rescue stuff. Okay. What has happened, according to the model that we were studying just a minute ago, The utility grid breaks down into many pieces called islands. In other words, we used to be one giant electric supply bus, and now they're all busted down into little tiny pieces, and that's really not a good thing, okay? Most of those island segments are gonna be without power, okay? Here in hometown, the dispatcher's just finding out that we're one of the many utilities that don't have any power. The neighboring utilities to the east, or excuse me, to the west and the north and the south are in the same boat we're in. They basically don't have any power to help us. The utilities that are up closer to Chicago are in much worse shape than we are, okay? Okay, all of our generating stations will have tripped. What's gonna happen is the E1 pulse, the one that comes through and destroys electronic stuff, basically killed all of the protective modules on the transformer relays, all of the control systems. Everything today is microprocessor control. They'll be torched. Okay, so now you have relays, protective breakers, circuit breakers on these transformers that have no control signal to say, turn me off before something bad happens. So we've got a lot of transformers that some of them might have tripped, some of them didn't. There's going to be issues. Hopefully none of them burned up. Local utilities presently on their own for getting restarted. Okay, the breakers that connect us to FP&L in one direction and to Georgia Power in the other direction and over to Alabama, those will all have tripped. That's why they call it an island. We're now an island of grid that's totally unhooked from the other guys. One of the really ugly things is that everybody in the United States today, just about everybody, the great majority of generating stations run on natural gas that comes via pipelines. Those pipelines run by giant combustion turbine or gas turbine units that use some of the fuel that they're pumping to run a compressor or a pump to push the natural gas through the pipelines. All of those have SCADA systems and control systems that are microprocessor based, and they're likely to have tripped off. It only takes one on a cascade of pipeline pumping stations to shut the whole monster down, right? It's like you close the valve on a long piece of pipe and nothing else is going through it. Okay, our solid fuel, the coal and coke burning boilers, they're the most complicated monsters that we have, and it'll be weeks and weeks before we see those suckers run again. The older liquid fuel, number 6 fuel oil, and diesel fired machines may save the day if control systems were not totally ruined by the EMP E1 pulse. We can count on little or no assistance from mutual aid crews because they're all in the same boat we're in. Can we get any spare transformers or breakers or insulators? Not likely, because the people next door are going to be having the same problems we have. Okay, I would predict that at Hometown U, the power plant crews are going to jump right in and they're going to bypass the electronic controls on our black start generator, which is like 2 locomotive engines back to back with a generator in the middle. And it's a monster generator that's big enough to start a power plant. So what you have to do typically is fire up the diesel and then transfer power from it through the buswork into our emergency gas turbine generators. They run off of diesel fuel. And so once you get one running and you can cascade power over and hopefully get those started, assuming that the control systems can be fixed or bypassed, okay? The lines guys, the guys in the bucket trucks, okay, so they don't have much of a radio system. So what they're going to have to do is they're going to drive around and they're going to go from substation to substation and manually open breakers to give us a clear bus. And that's going to be a slow and painful and hateful process, okay? The traffic locally, if you think 95 and 295 and the Buckman Bridge and Davis Point are a pain on a good day, imagine what happens now, because according to the testing data, roughly 5% of the usual traffic flow, those cars will be affected in some way by the EMP E1 pulse, okay? According to the testing done on vehicles in 2004 and 2008, roughly 5% are going to go stop dead and will probably not be restartable. Okay, so imagine the Buckman Bridge with 5% of the hundreds of thousands of cars that go on that sucker every day. They're going to be blocking everything. Traffic signals unoperational. You can't get gas at the local Magic Market. Cash registers are dead. The regional fuel distributor can't load fuel into the tank trucks to refill the tanks at the Magic Market. Refrigeration at the food retail stores and their supply warehouses is down. Cash registers, the emergency lights running in the stores, but the stores will not have any connectivity to their suppliers to reorder the groceries that are taken out. And that's assuming that we can find enough cashiers that can count change. Okay, that's a real problem. Okay, 8 days later, okay, that's the first day. It's going to really be awful. 8 days later, okay, we convert over to looking at each of the individual critical infrastructure sectors. Priority one is going to have to be restoring in the energy sector, restoring the natural gas pipelines and any liquid fuel pipelines, okay? And then local power restoration is going to have two priorities. Troubleshooting and repairing the high voltage substations, and then getting the generating stations working, okay? In the water and wastewater department, basically plant security and potable water and fuel are going to be precious. They're going to have to keep emergency generators online to keep the sewage flowing, which is really more of an issue than keeping the water flowing. I will leave it at that. The lift stations, as soon as you stop pumping sewage in the neighborhoods, it starts backing up into the houses. Not pretty. Our lowest priority is probably going to be fixing sanitary sewer overflows. In other words, places where the manholes are oozing sewage onto your front yard. That is normally their #1 priority, and now it's become their #4 priority. And then in the daytime only, probably the tanker trucks will be filled from the water plants and taken to shopping centers to distribute potable water to citizens. Mind you, this is all what I see going to happen, but I have spent a lot of time in the industry, and I have a pretty good idea of what's going to happen and what's not. Okay, communications, cell phone system resources, totally, that which works is going to be totally occupied by law enforcement, fire rescue, and the little bit left will go to utility recovery. COWS, which is the cell phone trailer on wheels, that's what they always take to earthquakes and to hurricane sites and that type of stuff. There's only a few of them, and how many cell phone towers are there in Jacksonville? There's got to be a zillion of them. Yeah, and the bright note is our local broadcast station, WOKVAM, is actually hardened for EMP, and that's not advertised. The only reason I know is because I know the engineer who ran the project, but I've never seen anything about it in any literature anywhere. FM broadcast stations, TV stations, they don't typically have emergency generators. They are huge power users, and it requires a big generator. A lot of them don't have it. We really need to get power and emergency fuel and generators to the internet provider facilities and the landline facilities, because everything works on communication. Everything depends on communication. The fire rescue trunking radio station here was damaged by E1 bolts coming down the antenna cables and coming in on the utility power connections. I've been there, I've looked, I don't see any EMP rated antenna protection or power protection on the systems. They're toast. Fire rescue capability severely handicapped by the fact that there's no telephones and cell phones to report into the emergency dispatcher. How do the fire and rescue people know where something's going on bad in the city? Because of the citizens calling in most of the time. So that's going to be gone. Okay, I can assure you that there's going to be a lot of citizens exercising their stand your right grounds. Everybody knows what that is, right? Defending yourself at home. The public safety, public utility people will be avoiding some areas to avoid contact with aggressive gang members and other citizens engaged in looting and collecting food, water, fuel, and other goods. Does anybody doubt that? I certainly don't. The first thing that happens is the governor will mobilize the National Guard to help calm down the hot spots. That's not going to begin to cover the problem. And the next step is basically an operation called Defense Support of Civilian Authorities, DSCA. The president basically enacts that, and then the federal government steps in to help. So where are they going to get all of the people, the FEMA and Homeland Security and people needed to calm down all of these cities that are affected? It's really going to be a tall order. It's going to be a mess. Food and agriculture. There's immediate need for electric power and diesel fuel for warehousing, refrigeration, food resupply from the factories to the warehouses, and from the warehouses to the school retail centers. Loading, shipping, logistics, which requires tons of communication. All of the response from the federal government is diluted because this is now a nationwide problem. The greatest majority of the country is affected by this. Most of the time when you have a disaster somewhere, help pours in from all points of the compass. That ain't going to happen now because everybody's got their plate full. Going to need renewed coordination between the railroads and over-the-road truck people. We're going to have civilian communications assistance to help organize and execute food transport and delivery. I think as ham radio operators, you can count on they will be knocking on your door. Okay, food and agriculture. Again, restoring transportation, raw materials, electricity, fuel to the food manufacturing people is going to be immediately critical. The standard level of stocking in your retail grocery store is 2 to 3 days. The warehouse might be a week. And then after a week, they have to be bringing in train loads and over the road truckloads to fill that warehouse back up. Okay. Hospital, the healthcare, public sector, health sector. One of our hospitals here depends on natural gas for on-site power generation. They're likely to be without power. There's no way to store those quantities of natural gas, and we do not have that storage facility. By that time, day 8, I'm guessing that maybe one major hospital will be back on 100% utility power, and the inability to get fuel and energy to power some of these hospital facilities is going to cause great amounts of death, especially amongst the elderly. All of the assisted care facilities, no air conditioning, no anything. I think we've already seen a little taste of that in the last year. Railroads. I suspect that about 95% of the locomotives that were south of basically the Mason-Dixon line will remain functional. Locomotive diesels, they have a small dependency on electronic controls. I'm hoping that we have some guys out there that are clever enough to get around some of that. But the bottom line is they're going to be far enough away that only a few of them, again, 5% of the total, will probably be affected by the EMP. The problem is the efficient railroad operations depend on centralized control, track signals, radio communication with the trains, and nowadays a system called hate getting old. Anyhow, it's a immensely complicated system that connects internet and satellite communications with the locomotives. And when something fails there, it basically causes the train to come to a screeching halt, and the guys are stuck there until they figure out what the problem is. Happens every day, every railroad at this time. It's a real problem. When you add in a little bit of mechanical or electronic failure, it's going to be a lot worse. Okay, the railroads are capable of defaulting to what they call loss of track control protocol, which basically is old-fashioned radio control, paper scheduling, and a few other things, and it's pitifully slow, and it will cause problems. Okay, think about all these trains that stopped How long do you think there's going to be trains stopped on sidings or in the main line someplace before people start figuring out that they're full of food and fuel? Okay, it's going to be an issue. Most of your locomotive radio systems are VHF. They will probably survive. Most of them will survive, but the trackside repeaters and the dispatcher base stations will probably be damaged somewhat because of the E1 pulse, again, following coax cables and power cables. The freight trains on the mainline tracks and sidings waiting for fuel delivery or motive power repair are going to be targets. Over the road trucks, most of those will probably continue running. Probably 90% is a guess on my part, based on what I have read from the testing that has actually been done. Okay, fuel supply and truck dispatching is going to be problematic. Dispatching is done by cell phone and by satellite communications nowadays, and we're going to probably be a little shy of that. And driving on the cluttered roads and avoiding groups of people that want your truck and its contents is going to be a problem. Aircraft. This is the one part that's just kind of grisly. I looked up, and in 2016, when I did the first of this, there was typically 42,000 U.S. passenger and freight air flights every day. And if you average that out, that's about 5,000 aircraft in the air at any given time. And the peak traffic hours in the East Coast are between 6 and 10, right after the EMP blast. So in the seconds after the EMP attack, basically you lose power in the airports. There's within a 500-mile radius of the attack blast, basically you're talking about all of the control centers going down. This is a map of where the major airports are in the United States. And you can see the yellow blast in the middle of the page. You can see that within 1,000 miles, there's probably 35 or 40 major airports there. The aircraft themselves are designed to deal with lightning, direct strikes by lightning. And most of the time, a direct strike causes very little issue. Maybe a little passenger instability. But the E1 pulse is most likely to get into the control systems on the aircraft, and most everything that's big nowadays is what it's called fly-by-wire. Everything uses quadruple redundant microprocessor control systems to allow the pilot to steer and to lift the flaps and lower the wheels and all that kind of stuff. I predict it'll be ugly. Nuclear power plants. Here's from the Metatech report. Here's a graphic showing where all the nuclear plants are in the U.S. and look how many of them are close to Chicago. There's in that red circle. There's at least 10, and that probably maximizes potential for control system failures in those nuke plants, permanent transformer damage, and the possibility for nuclear mess.
I'd be more worried if they hit.
What's that?
Said I'd be more worried if they hit Tennessee. There are more in that section right there by. Yeah, that's a little bit actually more worrisome.
That's Oak Ridge and all the.
Yeah, they're all over the place, and it could be an issue. Okay, in the nuke power plants, basically reactor plant physical safety, and that's basically guarding the facility. And then reactor safety is the next priority, cooling system backups, a la Fukushima. And then your waste storage facility, physical, I mean, while this is going on, it's a great opportunity for other people to play nasty games. There will be a critical need for diesel fuel for the emergency generators to keep the cooling systems up. Okay, on-site fuel supply is typically good for a couple of weeks. Okay, that's going to cause the feds to have to add more manpower and security resources in all these facilities. A little good news, the dam sector, the hydroelectric people, basically, those machines are relatively simple. They use electrohydraulic controls, and a good technician can go in there and make things happen with a screwdriver and a hammer, okay? And these machines, assuming that nothing has happened, nothing bad happened to the generators themselves, we should be able to bring them up relatively quickly and use some of that very reliable power to help bootstrap the rest of the utility. And if you look at our nearest neighbors, Georgia has 19 hydro plants, and hopefully that'll help minimize our need to ship electricity north, maybe to the west or to the south. But if you look at this map here over in the west of the map there in Georgia, there's quite a few hydroelectric plants over there. And at the very bottom of the map, you'll see that there's a hydro plant, believe it or not, in Tallahassee, and one on the Chattahoochee River over there. So here comes the IT sector. Based on my rooting around and reading, basically EMP shielding for commercial infrastructure buildings and their power and signal conductors is just now starting to be taken seriously. Okay, I'm guessing that we're going to lose. I mean, a server farm. Christ, you go up US 1 in Georgia, basically, in all the little towns, they have these huge concrete buildings that look like coliseums now, and they're server farms. And there's no windows. They have a big gate and fences around them, you know, but there's no real protection for the electronics inside. So somebody's going to have to go through and test all that equipment, pull out the bad cards, consolidate the you know, where they can, to put together some bits and pieces that will work together again. So hopefully with adequate manpower and electricity available, we can get the hardware, the backbone back up for the internet. The bottom line is the digital infrastructure is now a single point of failure for our country, and indeed for the rest of the world, because gosh, there's countries that depend on the internet more than we do. And I mean, this is one thing, if you could take it out, we are screwed. Okay, the digital infrastructure. And all that means is you have to take the power out to it, and sooner or later it's going to crash. And that's without damaging the rest of the system, just take the power away. Large banking institutions, oh my gosh. Everything runs on the internet, on the VoIP telephone, it runs on digital. I'm sure they have their own digital trunks to move big money back and forth. There's not a whole lot about that on the internet, surprisingly. But anyhow, the financial people, you know, if you shut down the financial people, you're going to really slow down the restoration of everything else. Okay, I would suspect that some of the local banks and credit unions will have somebody cobbing together emergency power. They will get their intranet internally to their building back up, and they will do whatever is necessary to try to put some cash out in the hands of the public. Okay. The chemical sector, that's businesses that deal with anything chemical. We have a number of local businesses that fall under the category of Homeland Security chemicals of interest. Okay, and that includes compressed gas suppliers and chemical manufacturers. And we have 8 rail yards in this city. I'm a rail fan, so I keep an eye on that. And if you sit there and watch the trains go by, and you know what's in those cars, and you certainly can by just looking at the numbers that are on the side of the car, the DOT numbers, it's pretty darn scary as to what and how much we have sitting on the ground with no protection. Okay. Government facilities like the arenas and that type of stuff. They'll be using those for securing them and using them for distribution of food and water and critical medications. And once again, able-bodied people will be offered opportunity to help. Maybe get paid food for work. And there's going to be a tremendous need for communications there. The other stuff that goes on, critical manufacturing here in town. I looked around to see what we have that's what I call critical manufacturing to support the critical infrastructures. Electric generating system, turbine and motor repairs, rail car and locomotive repairs, airframe repairs, storage battery manufacturing, and I can't read the one at the bottom there. Defense industrial, most everything out there is going to be shut down because of electric power and the ability of people to get to work. I mean, that's going to be a huge problem. If we can't get gasoline, we don't have traffic signals and all that kind of stuff. There'll be a tremendous need for security. Okay, so switch gears for a second. This slide was originally aimed at the infrastructure managers that I was speaking to. But what I'm asking you folks to do is think of what can you as a citizen and a ham radio operator do to be prepared for such an event. Okay. You'll find out as a mom or a dad or as a ham radio operator that there's going to be new and previously unconsidered responsibilities. Do you have a family plan for emergencies? Is your household prepared for a long-term disaster? 2 to 3 weeks of non-perishable food, water, shelter, meds, cash, fuel, and a means of protection? Do you have an independent means of communicating? My experience over the last 20 years going out after hurricanes is even the help, and I'll leave them nameless as to which ones, run off to the hurricanes and think they're going to use their cell phones. Ain't going to happen. Is your personal vehicle prepared to deal with stuff like this? How many people have more than a half a tank of fuel in their car at all times, you know?
Alone emergency kit?
Your business. Everybody here works somewhere. Most of us don't anymore, thank goodness. Does your business that you work for have a continuity plan? Will it cover an EMP scenario? Do you have backup power, means to keep it running? Reliable, independent communication? Do you have business supplies? I mean, when you stop and think about it, a lot of businesses no longer even keep paper forms and that type of stuff around, pencils and papers. Do you have a way as a business to keep the food and water and personal needs for your employees 3 or 4 weeks? Do you know how to protect your electronic gear? That's a whole presentation all by itself. There's a couple books out there, a couple of sources that are really, really good. A lot of my numbers that I use to make judgments here came from the EMP report from 2008. It was commissioned by the US government, the Armed Services Committee. And you'll notice that the subtitle is Critical National Infrastructure. That's what they were worried about, what we're talking about here. 208 pages. There's the link that you can download it from. It was intended to be easy to read by the average citizen. It's an excellent report. There's a newer and more comprehensive one that's come out in 2016, and it was written, I mean, it's basically the EMP protection and restoration guidelines for equipment and facilities. I mean, and it was written by the guys that know their stuff. There's no popular mechanics and popular science in any of these reports. If you need to get a feel for what we're talking about here, if this report hadn't done it, read 1 second after. It's a fictional novel. It's written by William Fortson. It was commissioned by Newt Gingrich in 2007 or 2008, trying to get some awareness of this problem. And then all these reports, official report to the U.S. House of Representatives, all of that stuff is available. This little cartoon is very, very appropriate for what's going on today. For quite a few years, we've kind of been leaning back on our laurels and things have been awfully quiet on this field. But in the last few months, this issue is going to come back to life again. North Korea and Iran. And in my opinion, based on a hell of a lot of research, they are the two that are most likely to cause us issues. So just keep that in mind. That is all. That's probably more than you wanted to hear. If you have questions, please contact me at my email address here. I have, of everything that I've done or said, I have the documents that information came from. If you'd like to question any of it, I'll be more than glad to send you the PDF of all the white papers and all that kind of stuff for that particular piece of the subject. Are there any questions?
So we can start taking questions in the room if there are any. If anybody online has a question, please use the raise hand feature icon thingy. And then we'll address the questions.
Okay,
online.
you may have to adjust the screen.
Yep, I will.
Are there any questions in the room here? I think everybody's falling asleep on me. That's good. Nobody's doing anything yet.
I don't know if sync's the right word.
What are you gonna use for the raised hand? Is that, Discord?
You'll see here like a little hand pop up. Oh, it's like there are
No hands. Look, no hands.
I think we're still in shock.
When I gave this presentation to InfraGard, took a full hour, and there was about 30 more slides. And there was a whole lot of people that left their lunch mostly untouched on the plates.
Yeah, I was one of them. I was there.
Does anybody online have?
I don't really have a question, but I definitely appreciate the presentation and the scenario. I'm going to email you as well because my family are preparing, and this is another great scenario. So I appreciate it.
Okay, Marilotta, if you'll send me a note at my email address, t.lovelace@comcast.net, I
Yeah.
can send you the PDF form of this file. And it'll
Okay.
actually have additional slides, and you can ignore the pretty colored slides and just read but there's a lot of very good information, plus
Right.
links to a lot of the books and papers and all that type of stuff I use.
Right. I really, really appreciate the presentation. It's definitely needed. I think we're right at the brink of all this, so I really appreciate that.
Well, you're quite welcome. I hope not, but it is a subject that concerns me.
Yes. And
Anybody
being
else?
prepared is.
I don't see are there any other hands raised?
No, if there's no other questions, we'll hand it over to Justin, I guess, to close out the meeting and